Hello and welcome, my name's Ryan, I'm also known as RM2K Dev. In this video, we're going to carry on from the last video. It has been a week since I recorded that video, and I'm sorry that there was a bit of delay in getting these out. I actually wasn't in the city last weekend, so I didn't get to record these videos last weekend. Thankfully, I had a couple more buffered up, ready to upload to YouTube. They're just big files, so they take a long time to upload. But thankfully, I had a couple that I was able to release last week. So, first of all, you're going to have to forgive me if I'm trying to catch up on where we are, because like I said, it has been a week and a half since I've looked at this code. And with that said, let's get started. So I think we left off our game and we just finished making these two rooms. One was blue and one was red. One thing I'm going to do is I'm going to bring up RoboMongo. So just let me pause. Okay, and just have a quick look in our database to see that our A character is currently on RM map home, which is correct because we're going to be using the A character just to debug. So RM map home, we need a tile set. The first thing that you will need to do is include a tile set in your game. I'm just going to add some of these in now. Okay, so I'm just going to create a background. I'm going to call this BG underscore tile set. You can name this whatever you like. And I need to load a tile set from my RM2K Dev MMO project. And let's bring one in that has the grass tiles in it. I think it is this one. Yes, it's this one. Just make sure. Yep, it's this one. Okay, then I'm going to go back to RM map home. I'll probably speed this up in post for you guys so you don't have to watch me make a map, but I'm basically just going to make a very simple map that our player can walk on. So what I'll do is I will probably... Oh my gosh, I've completely forgotten how to use GameMaker because I haven't used it for a week. No, I'm just kidding. We need to actually make our background into a tile set, of course, and I'm going to leave this at the default 16 by 16 just because it gives you a little bit more power in editing when you do that. So if I go to tiles, now my background will appear. Let's expand this a little bit and let's find some grass tiles. And what I'll do is I'll just place some of these down. I'm just going to make a very simple map. For my demo, you can make your map as elaborate as you would like. Okay, so I've just finished off my map really quickly. It's nothing special, but this is just going to be something that we can use to place our player in and have them move around. So now that our map's done, we can begin creating our player object. I think we haven't started creating the player object, so let's add a group called players. And I'm going to add a new sprite into that, and I'm just going to call this SPR hero underscore down, and we will edit the sprite and we'll create it from a strip. This is totally up to you how you do this in your game. I'm just going to do it like this for mine because I'm using a strip of characters. So the one that faces down for me is number 2, so 0, 1, 2. So I'm going to set my vertical cell offset to 2. They are 64 by 64 pixels tall. Let's set my offsets back to 0 again. Vertical offset is 2. There we go. So that's going to give me the third row. And there are 4, 8, there are 9 images, and there are 9 per row. So that will select all of these for me. If I press OK, GameMaker will chop those out, and then I have a nice walk cycle for my player. I'm going to center my sprite on this one and select OK. So now that we have a sprite for our player, we can create a group of objects, and we're going to call this one here players. And this is going to contain 2 objects. We're going to focus on the local player first. We'll add the network player in the next video. So I'm going to call this one object player, and in object player, we need to set the sprite that we just selected. I'm going to use sprite down, and that will pretty much be all we need to do for now. We'll come back and start filling in code inside of this object fairly soon, but I think the first thing we need to do is actually get this player onto the map. Oh, I've also forgotten that we need to make this one persistent because our player is going to be the object that moves around the world, and we don't need to recreate that every time. So we're going to make this one persistent. So from this point, we can go back to our handle packet function inside of it's a script, so back in handle packet, and we've left the comment from the last video, initiate a player object on this room. So I'm just going to open up my sample code here so that I've got something to reference when we do this. So we know the room that the player wants to go, that the player is asking to be placed in. We know the position, the positional data X and Y. We also know the name of the player. Now what we can do is actually initiate a player onto the map. And to do that, we're just going to say with, and then we'll use the instance create function, instance underscore create. We're going to create a instance at target underscore X and target underscore Y. It's going to be of type object underscore player. So when you log into the game, what you will end up with is I think that's right, I'm missing a bracket here, sorry. So there we go. And then with this object that we've just created at this position, we'll set the name to be equal to other.name. So other is referencing the scope. So if you imagine this as a scope, with is one scope. So other.name is like the scope before this one, which is this if statement, is going to take .name from here. So it's like go out of the with and then get the variable that was on the outside. Okay, so name equals other.name. And I think that is all we need to do. So I'm going to fire up my server by jumping back into WebStorm. I'll start up a instance of my server. We'll jump back into GameMaker and see if this works. All right, so for username, I'm going to use A, and if I log in, it should place us into the pink room. It's placed us in the pink room, I think, because I'm looking at the wrong database. That's why. I should have been looking at the test database, where A is placed into rm map test. So if I edit this quickly to say rm map underscore home, save that, and then I run my game again, we should be on the correct map in the correct position. If I log in with A, there we go. So we've been placed at the correct position on our map. You'll notice there's some issues with the view. Let's sort those out now. So what we need to do is go into our room, rm map home. We need to enable the use of views, make sure that the view is following our object player. Now, I can't remember what the dimensions of the room are, so let me check my sample project. 640 by 360. Okay, so the visible when room starts needs to be checked. Then the view in the room is going to be 640. The width is going to be 640 and the height is going to be 360. And the port on the screen is going to match that, so 640 by 360. The port on screen will already match that. This is because of application surface being set in the RM init room. And the other thing we do to get the player to be centered perfectly is we just make the H border and the V border greater than the width and height of our room. So if I make these both 1280, then our player will be centered in the view. So let's run this again and just confirm that our changes are working. And if I log in with A, there you go. So now you'll see that we have a player standing at the position that they're supposed to be standing at on the room in question. And if we changed that room in the database, this would also reflect and update that as well. So now our player is all set up, we can jump back into the player object and we'll start adding some code. We'll add a create event, and in the sorry about that, guys. I think my editing software just did something really weird. So I'm going to start that sentence again. Anyway, so we're going to open up object player. We will go in and add a create event, and we'll drag a code segment into that create event. So we're going to do a Pokemon style movement here where the player is locked to a grid. And to do that, we're going to say moving equals false. This is going to be our are we moving yes or no check. We'll have a target X equals X and a target underscore Y equals Y. So what this is doing is when the player is created, we're basically saying, remember where we're standing right now and store that in target X, and also say that we're not moving. So we can close the create event now. we will create a step event next. So I'm just going to add a step event, and we'll add a code segment to this. Now what we'll say is if target underscore x is greater than x, so basically if we've said that our target is somewhere to the right of where we currently are, then x plus equals 4. So we're going to move the character to the right. We're going to do this 4 times, so I'm going to copy paste that 4 times, and we're going to change it so that the second one is if target x is less than x, then we'll say negative equals 4. Now we're going to do the same for the y variables. We'll say if target y is greater than y, or less than y for the fourth one, so greater than y for the third one, less than y for the fourth one, we will say y plus equals 4 if it's greater, and negative equals 4 if it is lower. So basically, if we set target x and y to anything other than what you're currently standing at, the player will move in those directions. So now the next thing we need to do is reset our moving status, because what we'll do is we'll set the moving status to something else so that we can't move again. This is going to be like a debounce check. So we'll say if keyboard check. We'll say if target underscore x is equal to x and target underscore y is equal to y. So basically, if we are at the same position, then we will say moving equals false, because the character is no longer moving. So hopefully that made sense. Now we can go down and actually do our movement checks. So we can say if keyboard underscore check, we're just going to use the vk underscore left for this. If the left button was pressed and the player was not already moving, so not moving, then what we need to say is target underscore x plus equals 32, and we'll also say moving equals true. So hopefully you can see how this works. If you press the left button, that should be negative 32 because we're going left, and the player was not moving, then target x is subtracted by 32 pixels. And we say moving is true. So now what happens is the next time this step event happens, the target x will be less than the current x position because we're targeting somewhere else. The player's actual x coordinate will be adjusted appropriately, so they'll move to the left by 4 pixels. Then we'll run the check to see if we're still moving. So basically we are currently not the same, so this condition is not met, so moving remains set to true. And if you're holding the left button down, this time this code won't execute because the player is moving. So it's not moving. See, this will only happen if you're not moving. Sorry about that. This is kind of getting a little bit confusing, but hopefully it all makes sense. So I'm going to run the game and we'll have a look to make sure that we can move to the left. If I hold down the left key, you'll see that we move to the left. If I tap the left key, we take 1 step to the left. So now we can quickly just copy paste this 4 times and implement the other 4 directions, which I will do now. So I'll pause the video and show you when this is completed. Okay, so I've just added the left, right, up and down code, which is identical to the first one that we created. It just changes the x plus equals, y minus, and y plus equals. So let me run the game and let's have a look and see if we can move in all 4 directions. So if I press down, up, right, down, and as you'll see, we've got a really smooth Pokemon style locked grid movement system. Obviously we have no collision checking right now, so let's add that in quickly. So I'll stop the game. So in order to add collision detection in, all we need to do is add another condition to our is this paused? Oh no, we're recording, sorry. All we need to do is add another. Sorry guys, like I said, I haven't recorded a video in over a week, so it's been a little bit hectic and I've actually kind of forgotten a lot of my process in the last week. Yeah, so we need to add another condition to our movement check, and that's just going to be that the place is free. So we can add solid objects onto the map and then it basically will not allow us to walk through there. So we say if place underscore free, and we'll just say x negative 32 because we're going to the left and at position y. This basically makes sure that the position that we're moving to is going to be free. So if we place a solid object onto the map, then place free will return false and we won't be able to move to the left. And now we're going to do the same for the right, up, and down. And again, for right, we just say x plus equals 32. For up, we say x and then y negative 32. And for down, y plus 32. So let me do that and I'll show you when it's done. Now, as you can see, I've simply added those conditions onto our keyboard checks so that our target will not change unless all of these conditions are met when our button is held down. So now we need something solid to collide with. I'm just going to create a new sprite group. I'm going to call this system. We can use this for events in the future, but at the moment, oh, what's going on with my mouse? Sorry about that. My computer is freaking out on me today. I'm going to select create sprite. It's just going to be SPR blocked. Let's just call it that. Edit the sprite, create a new one. 32 by 32 is fine. And we're going to use a half or 1/3 transparent red, doesn't really matter. That's just to indicate that the tile that you're trying to go onto is now blocked. So if we create a object group and we call this one system to match the sprites that we just created, and I'll create an object in here called object underscore blocked and give it the object block, the sprite for blocked, and select solid, which basically means that place free will return false if it hits a solid object. Then we can go onto our map and we can start blocking in some of these areas so that the player can't move through them. So I'm just going to do that and I will show you what this looks like when we are done. Okay, so I've just created some red collision zones. Now in my version of the project, I made the trees as tile set images, and I don't think you can put an object under a tile set unless you've set the depths correctly, and in my version of this project I haven't set the depths correctly, so it probably won't work, but in your version you can do that. That's just why I've blocked in the entire tree so that our player can't walk behind them. I'm gonna run the game and let's have a look and see what it looks like, and hopefully if all is good our player should be able to move around and get trapped inside of a tree. That's not good. Let's have a look what's going on there. Okay, so the problem is quite simple. It's the fact that I've got a 64 by 64 sprite that is offset, its origin is offset at 32 by 32. Now, if you have a look at the collision code that we used, well, I've changed it already. It originally was 32. Now, if you're in the center of the sprite and you subtract 32 pixels, you're going to be looking at the tile just below where you want to be. Where you're trying to get to, which the collision point doesn't exist at. So you need to make sure that your collision detection check is 1 pixel beyond where your player is actually going to end up to make sure that it touches that collision zone. So I've just changed all of my place freeze to 33 instead of 32. And if we run the game and have a look, the collisions should now be working correctly. There we go. So as you can see, I am no longer able to bump into the trees if I try to go left or right. And you can play with these values, just get the collisions to look how you want them to look. Or if you're following along with the RPG series, then you can also change this out and use the physics-based movement system that I implemented in that series. Now from this point, we need to get this positional data back to the server. So what we're going to do is we're going to create a custom event inside of our player. So if you go to other and then you go to, sorry, it's not other, I don't believe, it's not other, it is, no, it must be other. There we go, other, user defined, and 0. We're going to create a custom script inside of this. I'm going to give it a name so that we know what it actually, so we actually know what it is. I'm going to call it network send update player position. And I'm going to create a buffer called pos packet, which just stands for positional packet. Buffer is going to be equal to buffer underscore create. 1 in size, it'll be a growing buffer. Since we don't know how big it's going to be, I'm just going to say buffer underscore grow, and it will be aligned to 1 byte. Now in that pos packet, we're going to need to write the header for our packet, which is going to be pos. So I'm going to say buffer write. We're going to write into the pos packet buffer It's going to be a type of string, buffer type string, and we're just going to write POS for position, not the other thing. And then we're going to write the player's X and Y coordinates. So I'm going to say write. We're going to be writing to the same buffer, so I'm just going to copy all of this and paste it in. We'll change this to buffer underscore S32, which stands for unsigned, not unsigned. Unsigned would be U, so it's signed 32-bit integer, which basically I think that means it's only ever going to be above 0. Because if we look at our maps, the top left corner is 0, 0, so our X and Y positions are never ever going to be over here in this negative space, so we can use a signed integer, which basically gives us numbers only above 0. And they're going to be 32 bits in length, which is huge. You're never ever going to have a problem with this, unless your players exist at like position 10 billion something, which probably wouldn't work in GameMaker anyway. So we're going to send the target X and target Y variables, target underscore X, and we'll do the same for the Y, target Y, and then we'll write that to the network. So network underscore write, we're going to send it to network.socket, since we've established that in our network create event as, oh, it's gone off screen, as socket. We can do this, so we say network.socket, and we'll write the POS underscore packet. Now our network write function will handle the destruction of this buffer, so you don't have to worry about any memory issues there. That will be taken care of for us. So now that our player has an event to actually update the position of the player, we can go back into our movement code, and just at the end of that, we're going to say event underscore user 0. So basically, after we've established that the player can move, we update their target position, and then we send their target information to the server. From this point, the server should be able to deal with that by sending that information to everyone on the map, and then that will establish our network players, which we'll deal with in the next video. But for now, let's just make sure that this actually works. I'm going to save my project, quickly give it a run, log in as character A, and if I make a movement, we don't have any bugs. And I think if we jump onto the server, we should see interpret POS. So basically our server has received the POS packets. Let's have a quick look at the interpret function. Obviously we haven't created that yet, but the server knows how to deal with the header, so it is receiving positional data. And if I bring the game up again, you'll see every time I move that the player is sending new POS packets to and from the server. And as we hold the button down, if I clear this console, clear all, here we go. If I hold the button down, you'll see it sends only one for every 32 pixels that we move in our game, which isn't really the most optimal way to do it, but this is a very simple demo and works absolutely fine for our purposes. So thank you guys for watching. Sorry this video has been a little bit disjointed. Like I said, I haven't had a chance to record a video in a very long time. Normally I record videos every day, so the process is quite fluid, and I haven't seen this code in over a week, but it went pretty well. So don't forget to give it a like and subscribe to my YouTube channel. And if you haven't already, jump back to episode 1 and give episode 1 a like, because every time episode 1 gets a like, it appears higher in the Google search results and more people will find this tutorial. So that would be awesome if you could do that. So thank you for watching, guys. Bye.